you close your column formwork without checking this, you're risking a major site mistake.
Good day everyone, here are the things you need to check as a QAQC inspector or as a site engineer before closing the shuttering or formwork of a column or shear wall. First thing you need to check is the grid line or surveyor markings. In our project, our allotted markings is 20 cm from the actual column, wherein our concrete cover is 4 cm. So from the links, it should be 24 cm. Next, we'll move on to the checking of the reinforcements for the columns and shear walls. Let's start with this column right here, the CA2 column. As QAQC inspector, our first step is always to verify the shop drawings. We need to check the specifications including the diameter of the bars, the spacing, and the type of steel required. So for this CA2 column, let's pull up the drawing and confirm it if the actual site installation matches what's required. This ensures the column will perform structurally as designed and helps us avoid any potential quality or safety issues down the line. So first, let's check the splicing length of the column reinforcement based on the approved drawing. According to the detail, the required lap splice is 50 times the bar diameter. In this case, we are using T20 bars, so we calculate 20 mm times 50 equals to 1000 mm or 1 meter. This means the minimum lap length should be 1000 mm or 1 meter. Now we have verified the actual splice length on site, and it measures 1 meter, which is the required 1000 mm. That means the splicing provided here is acceptable and complies with both the drawing and standard requirements. We are doing this splice because we are currently at the 5th floor level of the building and the column has future bars extending upward. These bars will be spliced with the next vertical reinforcement once the next floor is cast. Let's now check the vertical reinforcement. In the lower floors, the bars used are T25. But here on the upper floors, it's reduced to T20. This is normal because lower floors carry more load, so they need bigger bars. As the load decreases on higher levels, smaller bars like T20 are sufficient. Next, we verified the quantity. On site, we inspected and found 20 vertical T20 bars. The drawing, however, shows 22 bars, which appears to be a typographical error. To confirm this, we cross-check with other similar column details and they consistently show 20 bars. We recommend raising an RFI or request for information to verify and document this officially. So, always double-check both bar size and quantity before casting to ensure compliance with structural requirements. Next, we check the spacing of the links. As per the approved drawing, the spacing is 160 mm near the top and bottom, close to the slab soffit level or the SSL, and transitions to 200 mm at the midspan of the column. This because it helps resist higher shear and confinement forces, while wider spacing at midspan is sufficient due to lower stress in that area. Please take note also that it is acceptable if the spacing for the links are much lower than in the approved drawing, but please do verify if it still met the minimum spacing as per the design. We also verified the type of lateral ties used, whether they are single or with cross ties as shown in the drawing. We need to make sure proper hacking is done on the surface of the structural slab level to ensure a good bond between the old concrete and the new column or shear wall. This roughens the surface and improves the mechanical connection of the joint. No hacking, no bonding, and that can lead to future structural issues. Next is applying a releasing agent or sometimes the grease oil to the inner face of the formwork or shuttering. This prevents the concrete from sticking to the plywood or formwork, making removal easier and helps avoid damage to the surface of the newly cast column. So finally, there are just a few minor issues that I have observed in this checking of reinforcement. Some links are slightly swayed or misaligned as you can see in the drawing, and I have already instructed the foreman to realign them properly and clean the reinforcement before closing the formwork. So that's all on how I check the reinforcement of our columns in our project. Lastly, before closing the column formwork, we need to check for MEP clearance. This is very important because missing MEP clearances often lead to drilling or cutting through hardened concrete, which can weaken the column and compromise the structural stability of the column. Ensuring this proper clearance before casting helps avoid future issues and keeps the structure safe and clean. So that is all you need to consider before closing the formwork or shuttering of a columns on site.
If you found this helpful and want more videos about construction, QAQC, and site inspections, don't forget to like, follow, and subscribe to the channel. See you on the next one, engineers.